In this video, we're going to be taking a look at exponential growth. This is our unit on growing. And so first we're going to take a look at this thing called exponential growth. What is it? How is it used? How is it seen in God's amazing world? And so those are some of the difficult questions that we're going to try to answer. We're going to learn exponential growth by cutting paper, reading stories, and kind of learning about this thing through the lens of ideas and other stories. Now let's take a look at making ballots. So first of all, let's understand the problem. Chen is the Secretary of Student Government Association. He is making ballots. So Chen starts by cutting a sheet of paper in half. So that's right here. He cuts this piece of paper in half. Then he stacks the two pieces and cuts them in half again. So right there. Then he continues to cut them in half, and eventually his scissors won't be able to cut them, but he goes as far as he can. And so that's the story that we're looking at to help us understand exponential growth. So here's a simple table to help us understand the number of cuts and then how many ballots he would have after that many number of cuts. Go ahead and copy this in your notes under 1.1 and then come back to the video. Now, once you have that in your notes, we're going to use that table. We're going to fill that table out for the first 5 cuts for part A. And all along, we're trying to answer this question. How many ballots are there after n cuts? And what is that pattern that we're seeing? So the pattern that we're looking for is the pattern that's going to appear in this column. We're looking for that pattern, that relationship between the number of cuts and how many ballots. Let's take a look at problem 1.1. Number 1 says make a table to show. So go ahead and fill out that table. For the first 5 cuts, you are filling out this table. That's what you're doing for number 1. And number 2 says look for a pattern. Use your observations to extend the table up to 10 cuts. So now you're taking this table and extending it all the way down to 10 cuts. And then after 10 cuts, how many ballots would that person have? Now, could you actually cut it 10 times? No, it doesn't matter how large the piece of paper, there is no way. So this is theoretical. If you want to go ahead and try it, but I'm telling you, you won't be able to do that. But let's go ahead and just fill out this table up to 5 and then out to 10 and look for patterns. See if you can't figure out a pattern. Once you're done with that, come back to the video. And I just wanted to make sure that you knew there was a lab sheet. If you didn't get the lab sheet in class, ask for it. Or you can go on my website and print this lab sheet out. And you can just use this in your notes. It has everything for you because we're going to end up graphing this equation here. So go ahead and grab this lab sheet if you don't have it and answer this question on the lab sheet. So here's our table. We have the number of cuts 1 through 10 and the number of ballots. So after 10 cuts, you should see you have 1,024 ballots. Very little work to get a huge result, which is kind of cool. Just cutting a piece of paper or making 10 cuts. Now again, is that possible? No, because the thickness of the paper will be too thick. You won't be able to cut it. All right, so that is part A. Now part B says graph the data and write an equation that represents the relationship between the number of ballots. So graphing this data, if we look here, we're going to use this graph down here. This is going to be represented by the number of cuts. And we're going to go from 1 to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then on the left-hand side, the number of ballots. And we're going to go, if you look at this, this goes up pretty quickly. So let's go by hundreds so that we can get all the way to 1,000. And so there we have on our left side, this is the number of ballots. So make sure you label those, and I'll highlight the labels here. Number of ballots, number of cuts. And let's go ahead and plot these points. Go ahead and do this on your own. Plot the points. And then on part B, number 2, it says, how does the growth pattern show up in the graph and the equation? And number 3, is the relationship a linear function? And explain that. So go ahead and answer part B, numbers 1, 2, and 3, and then come back to the video. So on number 1, we graph the equation. This is what it looks like. You're just graphing these points. So for example, this point right here is 1, 2, matching up with this relationship. And then this one would be 2, 4, and so forth. So at 6, this is 6 cuts. And at 6 cuts, there were 64 ballots. So this point is 664 and so forth. Okay, so we have that graph. Now let's take a look at number 2. How does the growth pattern show up in the graph and the equation? Now look at your y values. Remember, y is a vertical change. And so these are your y values right here. So we're asking ourselves, looking at the change, because x changes by 1, but the change in y is different. Because from here to there is plus 2, plus 4, plus 8, plus 16, and so forth. So it changes. So we're trying to describe that pattern that we see there and there. So on number 2, both y values in both the table on the left and the graph on the right, the y values change dramatically at a certain point. Right, so go ahead and answer number 2 to the best of your ability, knowing what you know and seeing what you see in front of you. And then on number 3, it says, is this relationship a linear function? Remember, the definition of a linear function is essentially you can draw a straight line through all of the points. If we try to draw a line through these points, let's do the best connecting the dots. You notice there is no way that our line is straight. So in number 3, is this relationship linear? Absolutely not. It is not linear. Okay, and that's because those points are not in a straight line. So it's not linear. And this is, we're going to get to this, but this is actually an exponential. Okay, and if we look at our equation, let's try to figure out our equation. How are x and y, how are the number of cuts and the number of ballots related? So we're trying to get, what is our equation here? If you haven't gotten an equation, pause the video and try to come up with that relationship between the number of cuts and the number of ballots, and then come back to the video. All right, so our equation is going to look like this. The number of ballots is equal to, so we'll say B is equal to the number of ballots. And little c is equal to the number of cuts that you have to make. So the total number of ballots is equal to 2 to the power of, we use c for the number of cuts, so it's going to be c. Okay, and we can test that out, and we might have to use our calculator for some of these because it gets tedious, but let's jump at 4. Right, so let's test this out. Okay, is 16 equal to 2 to the 4th power? If our relationship is correct, this is how we're defining this relationship, because that'll tell us if we make 100 cuts, how many ballots we're going to have. If we could build a machine to actually do that, but again, that's impossible. But let's test it here. So 2 to the 4th. So 2 to the 4th is 2 times itself 4 times. So this is 4, that is 4. 4 times 4 is 16. So yes, it works. And you can actually test that against any of these. And if you take 2 to the 7th, you'll get 128. 2 to the 8th, you'll get 256, and so forth. All right, so this is our equation. Make sure you get this down, because that's very, very important. That is your base exponential equation. So we're going to be seeing that a lot because we're going to be taking these functions and moving them around a little bit. So make sure we understand what the, actually it's called the parent exponential function. It is the simplest exponential function amongst all exponential functions, and all others are based off of that. Now, if we take a look at part C, it says, suppose Chen could make 20 cuts. How many ballots would he have? How many ballots would he have if he could make 40 cuts? And how many would it take, or how many cuts would it take to make 500 ballots? So if you haven't already, go ahead and answer that. You will need a calculator. If your calculator is big enough, you might have to use a computer, actually, because I don't know if most calculators would have enough digits to answer some of these, especially the 40 cuts. So jump on a computer and type these in, see if you can't figure it out. But go ahead and do letter C, numbers 1 and 2 on your own, and then come back to the video. Okay, on C, on the first one, let's take a look at that one. So on number 1, it says if you can make 20 cuts, right? So the number of ballots is equal to 2 to the power of the number of cuts. So if you put 2 to the 20th into your calculator, you would get 1,048,576 ballots. Make sure you label all of these as well. Then if he makes, what's the next one? 40 cuts, it would be B is equal to 2 to the 40. Then the number of ballots would be this much. So there's hundreds, thousands, millions, billions, trillions. So you'd have 1,099,511,627,776 ballots. So you notice, even though we doubled the number of cuts, that doesn't just double the number of ballots, because if it did, we'd have about 2 million, but instead we have 1 trillion. So exponents are extremely powerful, which is why that's how they describe Superman's power compared to ours. Number 2, how many cuts would it take to make 500 ballots? So on number 2, you know that the number of ballots you want is 500. So then you would have 500 is equal to 2 to the C power. That's the number of cuts. And we're trying to figure out how many cuts that would be. So on this one, you're going to be guessing and checking. Go back to your table. Right? If you look at your table at 9 cuts, right? So if you had 2 to the 9th, that's 9 cuts, you would have 512 ballots. So that's going to be our answer, because you would need to cut 9 times to at least have 500. So in this case, it's going to require 9 cuts of that paper to get 500 ballots. You would actually have 512. You could not get exactly 500. You would have those 12 extras. That is it for this section here, 1.1, Making Ballots.